In this lesson, you're going to examine how does the shape, center, and spread of a distribution change if you add or multiply each data value by a constant. To understand this, we're going to explore 3 scenarios. So I encourage you to pause the video and work out these things on your own. Hit play when you're ready to check your answers. So here are the hourly wages of 10 students. So somebody gets $8 an hour, we've got a couple kids getting $10 an hour, etc. We're going to create a dot plot of the data. So love dot plots because they're super fast, super easy to do, doesn't take a lot of thinking. So I'm just going to number my number line. I don't need to scale it, so 8, 9, 10, 11, 12, and 13, and I'm just going to add my dots. So 1, 8, 9, I have 4 10s, 2 11s, a 12, and a 13. So it looks roughly symmetric to me. I'm going to find the mean, so I'm going to find the sum of my data. It adds to, let's see, 104 divided by 10 would be 10.4. So this is money. The mean wage would be $10.40 an hour. The range would be 13 minus 8, or $5 an hour, okay? Now we're going to go into scenario B. So if you work a holiday like Thanksgiving or Christmas, your boss has agreed to double your hourly wages. So let's double each kid's wage. So once we do this will be 26, we're going to create yet another dot plot of our data. So I'm going to scale this. I'm going to count by 2s to fit this on easily, excuse me. 22, 24, and 26. And I'm going to add my dots. So 16, 18, 4 at 20, 22, 24, and 26. So it still looks pretty roughly symmetric to me. You know, other than the values on the x-axis changing, I'd say it looks the same. So I'm going to find my new mean. And this time they're going to add, let's see, 208 divided by 10 would be 20.8, or $20.80 is my new mean. And yep, that's around the center of the distribution. The range would be 26 minus 16, so that is $10. And our third scenario is after a positive performance review, each worker was granted a $3 per hour raise. So not onto your holiday pay, but the original pay. So I'm just going to increase each of these by $3. And we're going to create a dot plot of our data. And let's see if it changes at all. Still looks roughly symmetric to me. I'm going to find my center. So the sum of my data is, let's see, 134 divided by 10. So my new mean is $13.40. And my range, 16 minus 11, would be $5. So now I want you to pause the video and answer the following 3 analysis questions. I want you to compare the shapes of the dot plots in scenarios A, B, and C. Then, how does the mean change from A to B, and then A to C? And finally, what's the impact on the range? How did it change from A to B, and then A to C? So hopefully you've noticed that the shape of the dot plots was the same for all 3. So adding constants or multiplying by constants does not change the shape. The mean changed from A to B, it doubled. Well, when we doubled each value, the mean also doubled. And then from A to C, it increased by 3. So adding is going to change the mean by the same amount as you add to each value. Now for the range also doubled from A to B, but from A to C, it stayed the same. So let's consider the big picture. What is this showing us? Well, if we add or subtract a value to each individual value, or if we multiply or divide, our shape is not going to change. So I've crossed out the shape here. Whereas measures of center, we looked at just the mean, but really we could examine the mean or the median because the effect is the same. If we add or subtract, we can just add or subtract to the measure of center. Same with multiplication, our measures of center will change. However, our measures of spread, which would include your standard deviation, your IQR, or just the range, they are not impacted if you add or subtract a value. So when we looked at adding $3 on, the whole data value is shifted to the right. The measure of spread, it doesn't become more spread out, so your measures of spread don't change. However, multiplying or dividing will change your measures of spread. So let's put this into play with an example. Each year, thousands of high school students take either the SAT or the ACT, standardized test used in the college admissions process. The combined SAT, math, critical reading, and writing scores go as high as 2,400, while the maximum ACT composite score is 36. Because the two exams use very different scales, comparisons are difficult. A convenient rule of thumb is that the SAT would be equal to 71 times the ACT score minus 150. Okay, so not perfect, but something that college admissions officers use to kind of figure out how it compares to the SAT. An admissions officer reported the following statistics about the ACT scores of 2,355 students who applied to her college in 1 year. Find the summaries of the equivalent SAT scores. So here are the ACT scores. Again, the maximum score is a 36. The minimum that they received was a 19. Here's the mean score of 27, standard deviation of 3, and some other reporting values. So we're going to figure out what is the corresponding SAT score using this rule. Right? So the minimum value is just a data value. So all we need to do here is take 71 times 19 and subtract 150. And that produces an equivalent SAT score of 1199. So let's find the equivalent mean score. So X bar is your mean. So mean is a measure of center, and they are impacted by both adding and multiplying. So if I do 71 times 27, subtract 150, that gives me 1767 for the mean SAT score. The next one is the standard deviation. Now, standard deviation is a measure of spread, and you need to be cautious with measures of spread. They're the ones that just work a little bit differently because they are not impacted by addition and subtraction. They're only impacted by multiplication and division. So I'm just going to do 71 times 3 to get a standard deviation of 213 points. So let's now find the 75th percentile, which would be another way of saying quartile 3. So quartile 3 is just a position in our data set, so it would be impacted by both the addition and subtraction as well as multiplication and division. So into the rule of thumb, I'm just going to plug in the 30, so I'm doing 71 times 30 minus 150 to get 1,980 for the value of the third quartile. Next is median. Median is a measure of center, and measure of center is impacted by both. So I get 1838 for my median, and IQR is also a measure of spread, so we've got to be careful with IQR. So only multiplication impacts my IQR. So I'm just going to do 71 times 6 to get an interquartile range of 426. Okay, so big picture is you've got to be really careful with your measures of spread. It's your turn to practice. Please seek me out if you have any questions.